All right. Thanks everybody for joining. Let's see if I can get this to work. All right. My name is Dave Urban. Welcome to the Southern California Splunk User Group meeting. Sean Ruthier, who is usually our kind of host, is out sick today. So our best wishes go to Sean that he feels better soon. My name is Dave Urban. I'm the senior sales engineer here at Splunk. Usually just kind of do more of the invites and setting up speakers and doing the recording and all that kind of background stuff. But I'll be the host today. And then our speaker is Mark Bonsack. He's a principal SE architect, and I'll go into more of his bio in a few minutes. Here's our agenda. So quick welcome. So thanks for everybody for joining us tonight. I'm going to go over some recent Splunk blog post highlights and an upcoming event. And then Mark's going to present on Splunk Connect for Syslog, and then we'll close after that. We'll have plenty of time for questions. So that's our agenda. Some of our more recent blog posts. One, cleaning up Hafnium shells and processes with Splunk Phantom goes through exactly that, how you can clean up some of those web shells in different processes in more of an automated fashion. One of a Splunk user was doing a lot of testing and then started wanting to use Phantom to kind of clean up his test environment and found different ways and methodologies with different playbooks to be able to do that, and he walks you through that. Another post was for those of you who have participated in our Boss of the NOC or Boss of the SOC programs. There has been a change to the Boss of the NOC program. Is now called BOO, which stands for Boss of Operations and Observability. So there's a blog post about that change, and we'll be sure to keep everyone updated on any regional or national or even global events around BOO and the Boss of the SOC program so that you can take advantage of those. The third was a post about Splunking AWS ECS and Fargate. This one's part 3. It has links to part 1 and 2. Part 1 is more about connecting your Splunk instance to your AWS account. Part 2 is talking about Splunking ECS in particular, and then part 3 is Fargate. So part 1, you don't necessarily have to watch or read part 2 in order to read part 3, but part 1 is probably pretty important if you haven't worked in that before. And then part 4, or you may not know that we have a sponsorship with McLaren Racing. So the Formula 1 season's getting ready to start. And there was a blog post about that. And also included in that blog post is a link and a discussion about data drivers. So this is a new program or a series of events that are going to occur monthly. And actually the first driving event actually happened today. And it is using iRacing.com, so esports and e-racing, and having people join and participate in a race to generate data. And then there will be a hackathon where there are different events with different tasks and different discussion points that happen about the data being added into Splunk and different things that you can do with Splunk. So it's a fun way to, if you're really into gaming, you can race, and that's going to generate a bunch of data similar to what we are gathering for McLaren Racing. And then you'll be able to go in and actually see how that data is utilized. You can just race and not worry about the hackathon. You can not race and do the hackathon, or you can just watch both and just kind of view it all without even having to participate. But if you want to join, the link is at events.splunk.com. Join _data drivers, and then it's all being broadcast on our Twitch channel at that URL as well, and I will post those into the chat during the presentation, and I will also make sure that this presentation is sent out to all of the attendees and people who are invited. So you'll have links to all of these for if you want to join and take part in that. So it sounds like a really fun event. I'm not necessarily a gamer myself, but I plan on jumping in on a few of those for sure. So those are some of the events and blog posts that have been posted recently and are coming up. And our next is our actual main event. So talking about Splunk Connect for Syslog. Mark Bonsack is going to be our presenter. He's a principal SE architect here at Splunk, and he's been here for about 10 years. Really has a passion for data acquisition or getting data in, or GDI. He's worked with a lot of our very large customers here in Southern California and the Southwestern US, many of which I work with now. So I get to be the beneficiary of a lot of Mark's hard work over the years. So really excited to have you on the call, Mark, and presenting today. And really appreciate you being willing to present to our group. So I'm going to stop sharing, and then I'll hand it over to you.
All right. Thank you, David, and welcome all. I am going to now share, and I'm just trying to see how this differs from Zoom a little bit to make sure I do the right thing.
Yeah, it's always a challenge.
I think it's calling this screen 1. So I guess I'll share the whole screen. I don't think I have any choice. It's kind of weird. All right. So let me move some of this out here. Okay, can you guys all see my screen? That the most prominent feature is taking control of port 514. Do you all see that? Yeah, sounds like you do.
Yeah.
All right, so I want to welcome you all to this afternoon's talk on Splunk Connect for Syslog. I am going to assume that kind of anywhere from never having seen Syslog to fairly adept at setting up Syslog servers yourselves. But in either case, it doesn't seem to matter whether we address newbies or experts. It seems to be a challenge. So myself and Ryan Faircloth, who is a principal architect, he's now a principal product manager on the security products. He and I, about 3-4 years ago, realized that as more and more devices continue to use Syslog rather than transitioning to an API or other mechanism, that we started to run into scale issues and configuration issues and performance issues with Syslog data ingest. So we embarked upon a task to understand what was really involved, and culminated in what we call Splunk Connect for Syslog. So we're going to chat a little bit about that today. And what it is it's a turnkey way at addressing the challenge of Syslog, which, as we'll see, has some unique features that make it difficult to deal with. So with that, as always, in many of these presentations you see from Splunk, we have forward-looking statements, which I'm not going to ask one of you to read out loud, but here it is. It'll be in the final deck that you receive, but suffice to say, I may say some things about future endeavors that may or may not be reality. So that's that. So what did we want to do? What was the ask from the customer base, and quite honestly from our own internal PS and Salesforce with regard to Syslog data? Because this is the constant ask we had from administrators, was how do we easily ingest this kind of data at scale while removing, and this is the big part, removing a requirement for upfront design work and basically Syslog foo. I don't want to learn the Syslog NG server or our Syslog. It's a pain in the butt. It doesn't work half the time. I just want to get my data in. And that really was the genesis of being able to answer that question, was the genesis of Splunk Connect for Syslog. And honestly, the first thing that popped up was scale. That was the first area where we really had issues with the older architecture. And over time, we realized, hey, we have a lot of folks that don't even want to deal with the configuration aspect either. So those were the two things that we sought to address with Splunk Connect for Syslog. So let's start a little bit and roll back the clock a little bit and see what the challenges have been over the years with Syslog. The primary one is that Syslog is a protocol and it's not a source type. And for years, the customer base and even those of us at Splunk have treated it as a kind of data. So we would, people would say, I want to collect Syslog data. Well, in reality, you want to collect Juniper data or Cisco data or Palo Alto data, which is the multiple formats that actually ride on the RFC protocols that you see in the upper left. But the protocols themselves are not the source type. It's the actual devices themselves. So it's kind of akin to the cars on the highway are what you're interested in, not the highway itself. We want to know if it's a red car, if it's a sedan or a coupe or a pickup. That's what we want to know. And the Syslog protocol, being as old as it is, presents unique scale challenges with traditional universal forwarder or traditional Splunk collection architectures. And again, the issue on the right-hand side was really the critical one that drove us to looking for a solution. People were just challenged with getting this data in at scale. And we'll cover a little bit about what those challenges are. But on the configuration aspect and the knowledge and expertise aspect, we have seen these issues arise over the years as well and continue to. And the key is there's been a lack of documentation and support for best practices. And it's largely because the tools that are deployed, namely the Syslog servers themselves, Syslog NG or our Syslog, are really end up being programming exercises. To configure them properly, they each have their own in a really domain-specific language. Our Syslog is a really bizarre language, especially the newer versions. And Syslog NG is largely C, coded or set up largely in C-style syntax. But even that is starting to become a programming language that a lot of the new folks don't use nearly as much as the newer Python-style languages. So shortage of deep expertise and documentation led to inconsistencies between server deployments. So you would task one customer with exactly the same set of devices. So collect Palo Altos, Cisco's, and Junipers, and you go to the next customer down the street, and there would be wildly different deployments that are solving the same problem. And that tasks the authors of technology add-ons, and it tasks both customers and professional services folks to understand each of these different deployments. And so a lot of times in response to that, folks a lot of times just throw up their arms and they just say, okay, we're just going to point it all at 514. That's why we titled this Taking Control of 514, at TCP or UDP 514, which is the default. Call it source type equals Syslog and let Splunk figure it out. But as we'll see, that really impacts the usefulness of Splunk analytics, and largely in the area of what we call the schema on the fly or schema at read, forcing the technology add-ons to unravel the differences between Juniper and Cisco and all of that. And they're wildly different. So asking Splunk to do that ends up being a real resource drain, and both on the ingest side and on the search side. And then again, scale, the way that manifested itself is we saw a lot of uneven data distribution between the indexers. So if we had 2, 3, 4 terabytes a day of Syslog coming in, we would see it massively. If you took any given 1 or 2 minute time slice, we would see 3 or 4 indexers out of 100 have almost all of the data. And then then the next set of 3 and 4 would have a bunch of data. And so if you do a 1 minute search, you may have 3 or 4 indexers participating in the search when you have 100 at your disposal. So the parallelization of search was really impacted. So we knew we had a challenge with this, and we needed to address it. And the reason it was a really big challenge from a customer perspective is this ends up being the dominant source type, and is to this day. Syslog is still a huge data source for most of our customers, and if they're a security customer, that ratio is even higher. It can be as high as 60 or 70% of the data is coming in over Syslog. And even in this day of cloud services like CrowdStrike and some of the others that have APIs, the traditional platform vendors have tried using that, tried going away from Syslog, and you have vendors like Checkpoint coming back to Syslog because of the fact it's so simple. One of the reasons that it is so challenging is that it's stupid simple. It's a send and forget protocol, but that presents some challenges, which we'll talk to architecturally. But it makes it real simple for the vendors to deliver logs at scale, which is what their job is. Their job isn't to deliver logs; it's to deliver firewall capability or routing capability. So in essence, this is actually telemetry from our internal systems, and we see Syslog as a source type is number one, and it shouldn't even be a source type. So we know it's a problem. We know that customers have a challenge, and we know we're seeing scale issues. So what have we done to deal with it? Well, the Splunk Connect for Syslog was the realization of our efforts, which we've outlined in .conf presentations for the last 3 years and in product form for about the last 18 months. And the goals were to make it a turnkey solution. So we needed to be turnkey. We had to have consistency and repeatability, particularly if we wanted to support it. This is actually the first supported Splunk solution for Syslog ingest. It's prior to that, it's been on your own. And of course, we needed it to scale. And if we achieved all those goals on the left, those three balls on the left, we would have much better data hygiene coming into Splunk, which leads for more efficient operations. And at the end of the day, much higher customer satisfaction and quicker time to value. So the goal was, quote, it just works. So when we get to the demo of this, it's going to be hopefully mind-numbingly boring, because Syslog in the past hasn't been boring, but our goal was to make it so. So hopefully we achieve that. So in any case, what we've done is a simple way. It looks simple conceptually, but it's difficult in practice to take the raw syslog that you see here, which happens to be from a Juniper IDP device, and translate it in Splunk with the metadata, the timestamp being proper, and the blue metadata that you see there being correct. And this is taken from a Splunk, a core Splunk system that is virgin. It has no TAs on it at all. So when it arrives in Splunk, it's properly source typed. So now the Juniper TA author or the Splunk user who's using this can immediately search against the source type of Juniper IDP and get Juniper logs back, and not have to deal with ferreting out or filtering out the Cisco and the Palo Alto logs from what might have been the case when source type was syslog. So it's a real conceptually simple task, but the way that the vendors violate the syslog standards, it ends up being a much more difficult task in practice to get this kind of output. But that's the goal. So to get it into source types with valid timestamps, which may or may not be in the header, may be buried in the payload, and with the proper source type to Splunk. And if the vendor is using the newer syslog protocols, you can even deliver it in a much more readable format, such as JSON. So that's a choice that you have. And you can immediately see here, this is eminently readable. This is the same raw log we saw 2 slides ago. But as you can see, if this is the way it looks like in Splunk, you're going to have a much easier time writing a TA or even writing searches off the raw data. So I am going to stop here before we dive into the architecture. And if any questions have come in, feed them through David, and he can feed them back to me, and we can chat about this, chat about them now. It's a decent break point. So if there's any questions, you can unmute as well. I don't know how Dave, you run these, since everyone is unmuted, but questions are welcome.
Yeah, you can feel free to unmute yourselves and or drop it in the chat, whichever one you want to do.
So does this, actually, I'll ask a question if there aren't any open-ended questions. Does this resonate with folks? Is this something that you guys are challenged with in general?
Hi, this is Daniel. Quick question. How does this differentiate from something like FluentD? Because we considered using FluentD as like our central syslog aggregator and then forwarding it with a similar kind of convention to Hack. I'm wondering what is the differentiating factor here?
As you'll see, and we'll get into the underlying architecture, we still use a open source recognized syslog server under the hood because of the fact that the protocol is old and the syslog servers are written in C, which is very, very adept at doing string handling, which is a hallmark of syslog processing. So using a facility that understands syslog rather than the transport protocol, just the listening on 514 has proved very valuable for parsing and for filter generation. So we sought to retain that capability, both because it was very functional and it also scaled real well. So we wanted a facility that was adept at collecting syslog independent of whether it would even land in Splunk. So we could have chosen something general purpose like FluentD or something like that to open a listener on 514, but then all of the parsing would have to be done. We would essentially have to completely reinvent the wheel. And some customers I've seen attempt to do that with Kafka as well, throw it all on a Kafka bus and then try to unwrap it all. But it turns out that the protocol itself does have some redeeming characteristics that make it real easy or easier to determine what's what and to parse things and to make it much more scalable. So we chose to retain a bona fide syslog server to front end this thing, is the short answer. So does that make sense to you?
Yeah, that gives some detail. Thanks.
Yeah, and we'll get more detail as we get into the architecture, which is a container-based architecture, and it made it easy also for customers and administrators that are familiar with Syslog NG. They could adapt some of their existing filters to SC4S. So it made it essentially lopped off a huge amount of work that we would have to do to properly curate the data. A big part of this is data curation, and I'll get into that when we show the demo and also talk about what's in the container. So that's actually a really good question, though. Appreciate that. Anyone else? And actually, I'll come back at you. I'll put you on the spot, Daniel. Are you having success with your approach?
We're considering it. We haven't moved forward with it yet. So,
okay. So what are you using now, just out of curiosity, to do the same thing, to do this, to take care of this?
We're just running Syslog NG on a heavy forwarder, and it's really clunky.
Yeah, so that's kind of the architecture you see on the left, right? That's what you're trying to do on the screen.
I'm just looking at it now, but yeah, pretty much.
Yeah, so let's talk about this a little bit and the challenges that we saw with that architecture. So, and that was our prior best practice. So, no one knew it, no one had any direction to do anything differently. But typically, we saw and advocated passing the network devices, any number of network devices through a load balancer and landing on a small set, typically less than 5, set of Syslog NG servers. And they would deposit the files to disk, and either a heavy forwarder or a universal forwarder would pick them up and send them on their way to the indexers. And unfortunately, I apologize for the graphic. That should read S2S or the Splunk to Splunk protocol, not HEC. So that is the traditional UF to Splunk mechanism. The challenge that we saw with this architecture about 3 or 4 years ago is when folks started to try to send much more than about a terabyte a day, and it was really bad at 2 or 3 terabytes a day through an architecture such as this. The forwarders were not and are not designed to aggregate data. So we would have thousands of devices coming in through a load balancer, and I'll talk about that in a second as well, where we would fan that out to a few amount of forwarders, and the forwarders that you see 3 of them there. In some installations, they were called on to write their data out or spray it out to 50 indexers. And unfortunately, the forwarders are not used to or good at doing that reverse pyramid scheme where there's a very few amount of forwarders but many indexers. The forwarders are used to contributing a small amount of data with thousands of them talking to 100 indexers rather than 3 of them talking to 100 indexers. So what would happen is when the forwarders load balance, they time slice, and over by default, a 30-second period, and things have gotten better with Event Breaker, but still not nearly as good as they need to be. But over a small time slice, maybe 30 seconds to a minute, you would have 2 or 3 indexers at the most getting the data. And the other 98, if there were 100 of them, weren't seeing any data. And then it would flip to the next set and so on. And that's a byproduct of the Splunk to Splunk protocol that's shown in green there between the forwarders and the indexers. So what would happen on the search side, particularly for things like data model acceleration in enterprise security, is the DMA acceleration would take forever because only a few indexers would participate because those searches run on a very small time slice. So what we needed is a much better way to distribute the data to the indexers. So what we did with the primary architectural change we made with Splunk Connect for Syslog, regardless of how we packaged it, was to change the transport protocol, to change it to the HTTP event collector, which can load balance, as you can see in the middle, very effectively because F5s and Nginxs and all those are really, really good at spraying HTTP. That's what they're made for. And so we could get very, very fine-grained and equal data distribution to indexers and much, much lower resource utilization on ingest and search out of our indexer tier. So we got a huge performance boost and resource boost on the Splunk side by going to the architecture in the middle. The other thing that you see in the middle is the elimination of what we call the front side load balancer. And that's a byproduct of the Syslog protocol itself. And even with TCP, it's a send and forget protocol. It's an unacknowledged protocol at the application level, which load balancers have a real hard time with. And in some cases, TCP for Syslog can even be worse than UDP. So my co-author, Ryan Fairclough, has written an excellent blog on why at scale you want to actually have your devices send UDP as long as the payload can fit within the UDP constraints. And most devices can, but some can't. But all things being equal, sending at scale, UDP is the way to go. But the only way for UDP to work is if you get that red box, which is our Splunk Connect for Syslog or any collector, Syslog NG, whatever you decide to use, get it out to the edge, into the management planes of your data center so that you're not having to pass through network infrastructure just to get the data to the collector. That's a huge, huge architectural change that a lot of folks have trouble wrapping their arms around, and it flies in the face of modern network architecture. But we have to remember that Syslog is a 40-year-old protocol and hasn't been touched in 40 years. And so some of the modern networking architectures don't work well with it. And front side load balancing, unfortunately, is one of those. And in real customer installations, we've seen 20, 30, 40% data loss when people try to aggregate or load balance like it's shown on the left. So the key with any Syslog architecture, regardless of whether you take or use or utilize SC4S, is to get the collection to the edge and translate your protocol into something that is load balanceable and routable, which is what is shown in the middle. So two main architectural changes. One is the elimination of writing to disk. So everything's in memory and on the wire, so it's much faster. And also getting the red boxes out to the edge and getting the collectors as a true edge protocol. So that is how we've architected SC4S, and we'll now explore what's inside the red box. But on the right, you can see we can now go into DSP, data stream processor, or Kafka. So we have a number of choices besides just the HEC protocol that we can send out the back end. So that's depicted on the right-hand side. So that's one of the advantages as well of using Syslog NG, is they have a number of free, in their library, pre-canned destinations, and Kafka is one of those, HEC is one of, or HTTP is one of them. So we took full advantage of that. And we've had really good responses from the authors of Syslog NG on a personal basis. So we've had real good support from those folks. So I will stop here, and this is often another section where we have a lot of questions and open up for questions.
Hey, a quick follow-up question. So you mentioned that we should use UDP, but doesn't that mean we'll lose messages if we're not using TCP? I'm a little confused by, I wonder if you can go into more detail on that.
Yeah, that's paradoxical. So in either case, UDP or TCP, it is a send and forget protocol. In other words, the device issues the packet. And in the case of UDP, it is connectionless. So it goes and it's best effort. Unfortunately, TCP isn't much better. You get the three-way handshake, but honestly, that three-way handshake can get in the way, particularly if you try to use a load balancer in the form of sticky sessions. And so you can get a whole buffer full of messages in your load balancer. And if the load balancer needs to go offline for maintenance reasons, you can lose a whole slew of messages because the server cannot issue. There's nothing when the device sends a TCP syslog message, it runs through the three-way handshake. So it does a little better about getting through network infrastructure. But there's nothing that tells the other than flow control. You can tell the client to back off, but there's nothing to tell the client that the server's not ready, such as a 503 error that a web server would give you, for instance. So you can't really take back-end services out of the pool and initiate a retransmit on the client side. So it ends up, and the TCP three-way handshake ends up being a higher overhead for the device. So in practice, it really turns out that UDP, when collected close to the devices, results in the lowest amount of data loss than using TCP. Now, there are exceptions to that. So if you use IETF framing, which gives a byte count in front of each message, and encapsulate it that way, you can get very reliable transmission that way. But many I should say many devices, or most devices, don't use that protocol, but a lot are starting to. So that's a good case to use TCP instead of UDP. For instance, Palo Alto, now you can wrap it in what they call IETF framing, and that provides a very reliable transport. But in most cases, especially for legacy devices such as Cisco's and even some of the carrier grade Palo Altos, where throughput is from the device is paramount, UDP ends up being better. So I will actually add, which isn't in our resources section at the end, I will add Ryan Faircloth, who's my co-author on Splunk Connect for Syslog. I will add his blog post, which really explains the whole UDP/TCP and load balancer thing in much more detail. It's a really good overview of that. So hopefully that helps a little bit, but the upshot is that even though TCP is out there, it is still an unacknowledged protocol. So you don't gain a whole lot. And in many cases, you hurt yourself. So good question, very good question.
Thanks for the context. I appreciate it.
Any others before we go on? All right, we do realize that we're coming 40 minutes after, so I will bump it up a little bit, and then we'll open it up for final questions. The architecture itself, it is a container architecture, and the reason we did that is Syslog NG being a really, really good Syslog server is open source, and it is often difficult to get the latest and greatest on any given distribution. That's gotten better over the years, and actually the years we've been working on this. But many customers attempt to use the Syslog NG that comes with the distribution of choice. And most of the time, believe it or not, it is 15 to 20 revisions old. So the distros do a horrible job at keeping up to date. And certainly with bug fixers, they're way behind. So we take the latest upstream distribution and package it with a disk buffer. And that disk buffer is useful if the connection to HEC goes down. So our transport, remember, is now not the file system locally, but it's directly over the wire to the indexers. So of course, there's a chance that that connection can be down. So we need to have some local disk buffering, but all of that is automatic. And then we bundle it in with a Red Hat Linux base image that is very secure. So it's the Red Hat 8.3 base image. And this slide deck's a little old. We actually have DSP connectivity now, so that's current. And HEC, of course, is available. And the whole Syslog NG infrastructure is open as well. So if you have another destination, albeit it won't be supported by Splunk, it can be used. So anything that Syslog NG supports, we can support here. Because we also mount, in addition to the disk buffer, we mount a portion of the local file system so you can have state and the configurations will be maintained when the container goes up and down. So that's how we've architected this. It's proven to be very, very easy to deploy because it really acts like a single binary in the host OS. So you can just launch it out of systemd, and I'll show that a little bit in the demo as well. So it's really easy to deploy as a container. So what happens inside? So how do we set this up? What Splunk Connect for Syslog is with respect to Syslog NG is just a very, very well-tuned Syslog NG implementation. And its goal is to identify, parse, and format the data that is well curated for Splunk. So on the left-hand side, we see an ASA event coming in over the default port, and we want to filter it, identify it, parse out the timestamp, anything that's relevant, and send it on its way to Splunk, pre-curated, or the source type is already dialed in as Cisco ASA. And so it will land as Splunk with that source type. And we actually use, for those of you that are familiar with HEC, we use the event endpoint. So even the timestamp is pre-cooked and sent to Splunk. So the timestamp processing on the indexers isn't even used. So it's super, super efficient on ingest. It's completely cooked data. Everything is handed to Splunk on a silver platter, including the timestamp. So all of that props and transforms things that you typically need to do for Syslog data coming in. You don't need any of that anymore, which is awesome. So that's what it does. And we do this for about 50, actually probably closer to 60 different source types now. So we have all the flavors of network devices, Junipers, NetScreens, Fortinets, all the typical devices you see out there. And our ability to turn a new device is usually less than 2 or 3 days. So we build this thing on a CI/CD basis. Ryan and I are continually updating this. So for those of you who have tried it. So that's how it works under the hood. And it's really as simple as that. It's just to get the data filtered and parsed properly. So some of the choices we made when we were designing SC4S is we realized that Syslog is a religion. And in many cases, it's way over-engineered. And probably the number one way it's over-engineered is the attempt at high availability. And that is something that is, again, is ameliorated by pushing the collector out to the edge and realizing that Syslog, the protocol, is, again, a lossy protocol. There is going to be data loss. I like to compare it to MP3 versus CD quality or lossless. You can make it mostly available, but never truly highly available. And using something like Keep Alive D on the SC4S servers is the best way to handle that, or even VMware vMotion. You know, at the end of the day, if you took a year sample, the amount of nines that you'd get by keeping it simple will outpace anything you try to do from an HA perspective. The other thing we realize is that Syslog being so, and the devices being so non-standard much of the time, that we weren't going to solve 100% of the problem for 100% of the people or the use cases. So for those folks, we do provide the configs in what we call a bring your own environment if you have truly unique circumstances. But we found out early on that folks said, oh, I want the control, I just want the configs. And they ended up coming back to the container after about 2 or 3 months saying, it's just easier to use the container. And now 99% of our uptake is the container solution. So, but it is available, everything's full open source. It's fully supported, but it's also full open source. So nothing is hidden for how we've configured this. Again, the primary need is primary goal was to satisfy those who just want to get the data in typically on the default. They're sending all their data to 514 and they just want it to work. That said, there were some simple customizations, like people saying we need to send our Junipers on 7514. And so simple customizations such as ports or CIDR blocks or host names that map to certain devices, that is configurable out of the box. A huge goal, as we stated at the beginning, we didn't want people have to learn Syslog NG to make this fly. So that was a big part of this. Restricted environments was a big thing. Again, we didn't want to have people having to download the latest and greatest Syslog NG when they might be in an air-gapped environment. So easy to deploy in a restricted environment was a big one. And then it, of course, needed to be turnkey. So we didn't, if someone came to us with Ubuntu or Red Hat, then it would deploy exactly the same way. So that's why we picked the container. And over time, containers are starting to become ubiquitous. So that was an easy choice to make. Yeah, much more easy even now than it was then. So out of the box, we, again, provide filters for about 60 devices that can send on default 514. And we really are only asking for a couple things. And the main things are the heck URL, where do you want to send it? And what's the token? And the default collection port is 514, that can be changed. And then how big do you want your disk buffer? So that's a risk management decision that any enterprise makes. How long do you think, if your connection to heck goes down, how long do you think it will go down? How much data are you collecting per day? Multiply the two together, and that's how big you want to set your disk buffer. And then you want to provision that on your SC4S servers. And these are all set as environment variables in the container config. So we'll go over that in the demo. So that's kind of wrap on the slideware, but the main repository, we will get this out to you. I will also add Ryan's blog to this before I send it out on the UDP TCP stuff. There is a 4-part blog series that goes over the fundamentals of operation and architecture, all the way to configuring for additional data sources. So it's a 4-part blog series. And then we are very active in the user group Slack channel and Splunk Connect for Syslog. If you guys haven't been there, Ryan and I are very active in the Slack channel. So with that, before we get to the demo, I will ask if there's any more questions while we go over to the demo.
There is one question in the chat, Mark,
Okay.
from Sasha. It says, is there something similar to Splunk Connect for Syslog that would take streaming UDP data in JSON format?
So streaming UDP, so just a generic UDP port where the data is coming in over JSON, but it's not necessarily formatted in with a syslog header. Does that accurately reflect the question? Yes.
Sasha, is that
Hi, this is Sasha. No, there is no syslog header. It's just data formatted in JSON. There is a timestamp. There are some other fields, but actually, there's an option to send data in syslog or JSON. And I'm wondering if the data is not syslog protocol.
Yeah, if it's not the protocol, we can handle it because there are so many vendors that don't obey the protocol. But if the vendor or the application has a choice, I would send it in syslog, and then we can handle it out of the box.
Okay.
But we see that all the time is people, and what we really see is, which is common, when vendors were sending, because one of the things that I talk about in a longer presentation in the .conf prezos is never, ever, ever send 514 or syslog data directly to Splunk. But a lot of the device vendors have advocated that and built TAs around that. And they have configurations in their own devices, which is called, a number of things, but many times it's called Splunk format, which is just name value pairs, which works great for our auto key value pair extraction, but it is not standard syslog. So when you change and try to use a syslog server, that format falls on its head or falls on its face, and we have to back ourselves out of that. So we're now educating the vendor community, the tech partner community, to send it in true syslog format, and we'll have a much better time with it. You can still maintain the name value pairs in the payload, but just put a valid syslog header in there, and we'll be much better off.
Okay,
that can be true for this UDP setup or this JSON setup. You can still maintain that format, but just make sure you have a valid RFC compliant header in front, and then it makes life much, much easier.
Okay,
So,
thank you.
Yep. All right. So now on to just a little bit of a quick demo. I'm going to run an all-time search, all-time, real-time, just to watch the events as they come in. And I'm going to now send some representative, and I'm just using netcap to do this. So I'm simulating a true device sending data. So I'm going to, and then I'll show you how the incoming data differs from what you see in Splunk. So first I'll send off some Palo Alto data, and you can, or Palo Alto messages. And you can see on the terminal screen in the upper right, and again, I'll ask if folks can see that okay before I continue. It might be a little small for some folks, but hopefully you can read it. Thumbs up from anybody?
Yeah, I mean, it looks good to me.
Okay, cool. So what you see, and this kind of goes into the gentleman that had the UDP JSON question. This right here, this 190, which is what they call a PRI string or priority string with a timestamp and a host name, is part of the syslog protocol that really is required. And that is decoded by Splunk Connect for Syslog. So the real message starts right here. From here to the end, that's the real message. So one of the things that is really cool about Splunk Connect for Syslog is it does a lot of data curation and makes your Splunk ingest more efficient and therefore lower costs. So not having to show you the 190 and the timestamp here and the host, that's all metadata. That's all down here. So you see host in here, you see PAN-W threat host, that matches what you see here, but it's metadata. You don't need to index that because that's taken care of for you. Of course, the source type is PAM threat for the first message and PAM traffic for the second message, actually, that's reverse chronological order. So, and that's gleaned, again, that's by us, the authors of SC4S, reading the vendor documentation and understanding that threat and traffic are the keys as to what source type these events should be. So again, the Splunk instance that you see on the left here has no TAs in it. It's just raw core 8.1.2 that I've installed. The other thing that's really cool is the metadata that we send in along with the raw message. So we send you the container it is. So if you have multiple collectors, we know which particular collector is sending the data. And this is great for monitoring. So you might want to use, I can't remember the traffic app that's really popular out there, or the monitoring console, to see that if there's a particular container that is not sending data properly or losing data, you can easily see that. What port it came in on, what host, where it came from, the host IP, which might differ from the host name, which it does in this case. And then the protocol it came in on, TCP or UDP. And then what the syslog format is that we have determined this to be, which again, almost all of these are going to be non-standard syslog because the vendors unfortunately don't follow the RFCs very well. So the other thing is that 190 that you saw here, that's actually an encoded value for priority or severity and facility. So user and notice is the decoding of facility and severity for 190. So that's what you see there is a decoding of this protocol. So a lot of metadata also comes in with the in addition to the indexed event. So that's an example of Palo Alto. So now I'll send a iOS string, which is much shorter. But this is, again, this is a classic reason why you don't want to set your source type to syslog. These events are so radically different that asking the TA to unwrap this on the Splunk side is a huge overhead. And that's something that you really should do prior to sending the data and getting it properly curated. So again, Cisco iOS, a much shorter message, 190 again. You have a whole header here, and you can see that this is almost 35% of the message that we don't need to send. And the message starts with the Cisco mnemonic that a lot of you would recognize. So huge cost savings on data ingest for Splunk. And again, relevant metadata. And even as detailed as this little star here, for those of you familiar with Cisco, you've got that little star in front of the timestamp. Again, this is a classic case of a vendor violating the standard for the header, but they do it anyway. And in this case, for a Cisco device, it means it's not synchronized with the NTP server. So the timestamp here may or may not be accurate. And Cisco's telling you that with this little star, but we actually report that as a Cisco time error. So that's the level of detail we've gone to in parsing these messages above and beyond just sending the data into Splunk. And this is the level of detail, going back to the gentleman with the fluent D question, that's really hard to do correctly without a syslog server helping you, and kind of rolling your own with syslog ng. And I'll show you one more. I think it's FortiGate. Yeah, here's one that is real interesting. FortiGate traffic, Fortinet firewall. Again, here's the priority string and the date of August 17th. You know, I just put a bogus date in there. But the point being is that this is one case where the header date timestamp is irrelevant. You don't want a timestamp off of that, which is what would happen in Splunk if you did it automatically, unless you wrote a TA to get around it. But in our case, we actually use the date of the date and time that's in the payload, and we actually parse that. So this date and time is actually what gets used to set the timestamp for the date. And again, in this case, the TA wanted the date and time. It's actually relevant part of the payload, so we kept this in there. But ideally, I mean, but in reality, we wouldn't need that either. But a lot of folks that are searching FortiGate would probably want those two, so we left them in. Again, the output templates are configurable as well. So you can include or exclude as much of that header as you want with environment variables. So again, this is an example of a format that, again, is completely different than the previous two, but that gets parsed automatically out of the box by SC4S. So I'll stop here for questions, and then I'll give you guys 2 minutes. I know we're at the top of the hour, and again, David, I apologize if this is supposed to end at 5. But let me know if I can have, if we have time for a few extra minutes of discussion, and we'll continue.
Yeah, no problem. Karthik, did you have a question?
Hey Mark, hey Mark, Karthik here. So
Hi, Karthik.
like if you are sending the data in a 514 UDP 514 port, like different datas like FortiGate, how the SC4S connect will go is going to identify those datas and pass it.
Yeah,
Like
so
I have a checkpoint logs, Zscaler, vector, all those stuffs I have, but how do like I can send all those data in a UDP 514 itself?
yeah, very, very good question, because most of the time, and you mentioned Checkpoint, FortiGate, iOS, you can send them straight to 514. However, if there is a source where we cannot identify a fingerprint in the data, and we cannot uniquely identify it as a FortiGate or as a checkpoint, you have to help it. There's no way, if we can't regex our way to a unique fingerprint of the data, then I cannot identify it automatically. So you have to tell us a couple of things to help it along. You can send it on a unique port, so you can choose a port other than 514, or you can tell us what CIDR block it's coming from, or you can tell it what host name wildcard. And that's how you do it. But for much of the data that we support, you don't need any of that because we can uniquely identify it. And that's the research that we've done with the vendors to uniquely identify it. So we have, so for instance, Palo Alto has enough of a unique footprint, such as this threat with, comma separated fields, that no other vendor is really going to use this format. So we're not going to step on ourselves by sending it to 514. But certain other devices like Aruba, I was just recently working with Aruba, and their logs are so sparse that we cannot tell from the payload because the vendor, in this case HP, does not put an identifying string in their data to uniquely identify it. That's where some of the newer Syslog protocols will help, but many of the vendors still stick with the old, what we call BSD Syslog, which was, really created in the mid 80s. It's that old.
Okay.
So anyway, hope that helps to answer that question.
Yep. I have one more question. Like now I have already ingested a sum of data, so I want to migrate it to SC4S. If I ingest some of the data like checkpoint and Zscaler, it has predefined source types. So I don't want to use a predefined source type which is used by SC4S. I want to like before I was using a customized. I need that source type itself to onboard those logs.
So you're saying that you have a custom
source types.
Source type. You can add them in a number of ways, and this is a good segue over to the configuration, which I will show you right here. So the configuration is. Oh, actually, let me start from. So hold that thought for just a second. This is a tree of the local file system that gets mounted by the container. Much of this is created automatically, particularly the context directories, because this is where you do index overrides and metadata overrides. But in here, in the local config area, is where you can set up custom, what we call log paths. So you can set up custom source types in there. But even before you get to that level, the main configuration file for SC4S is a file called env file. And that is a list of environment variables that are shown here. And this, again, it's real simple. It's what the URL is, what the token is, but you can also specify alternates. So here it's saying, I want to listen for Juniper NetScreen on port 5000. So you can for supported sources and ones that don't have a unique fingerprint, you can use that to set up alternate source ports. You can also set up, which I don't have in this config file, what we call simple source ports. So if your custom source emits standard syslog, and it can either be the new flavor or the old flavor, but as long as it has a syslog header, you can define what we call a simple port that says, I want to call it, my underbar source, and I want to have it listen on port 5010, and you can ingest it that way. So you can develop a custom source port that listens on a unique port. If you want to create a log path, though, that will work with UDP 514, which is what we call the soup port, which is where everything gets thrown into the soup, then you want to create a custom log path. And we have a blog post, or my part 4 on the blog post tells you how to create these. So here are some examples for IKEA and Stealth Bits that I created. And these are just standard syslogs. So they're stubs of the general configuration that you can configure as part of your installation. And as long as you are writing compliant syslog ng syntax, it will get used in the configuration. So that's how you can extend the platform. And last year's comp talk was exactly that, is how do you actually create these locally sourced log paths to extend the platform. So that's how you do it. So there's much more to that, and I know we're running out of time, but that in general, this file system is where you stub in your custom configurations.
Okay.
For custom source paths.
May I get the filters and local example config files? If probably.
Yeah, these are these guys. The LP example that comes automatically. So if you deploy SC4S, you're going to get the example TMPL files and instructions on the blog post as to how to modify them for use for real source types. And I will let you guys all know we are in the process of making these template files much simpler. So they were a little convoluted in the past, but now they're becoming much simpler. So stay tuned on that. In the next 2 or 3 weeks, you're going to see a massive simplification of this process. So, but no magic. So I can go down into this. Let's see, where am I? And one of the things that you'll see in the blog post is we actually have a templating process that we go through. So it's actually, he's changed this already. So let me just show you one of the older ones that I worked on. So this is mostly comments, but here is where we're setting up the listen ports and defining what the listen port should be, and then the source where we want to listen from it, whether or not we're checking to see if it's 3164 compliant, and then we have a filter F stealth bits, and then we're setting up a key for the overrides. Anyway, I'm getting way in the weeds here, but this at the end of the day, this generates standard syslog ng that if you're familiar with syslog ng, this will parse accordingly. So here we're, in this case, we're setting the source type to stealth intercept or SFM syslog, which is the 2 flavors that they have, depending what the program field is, which is one of the syslog fields for stealth intercept. So that's how we actually set the source type appropriately. And all of this is just standard syslog ng syntax. Again, we're in the process of making this much, much simpler, to where it's really just 3 or 4 lines of code rather than 50 or 60. So stay tuned for the updates on that.
Thanks.
But here is, again, back to the env file where most of the out-of-the-box configuration is set. Some of the things that you might want to set is whether or not you want to enable TLS, inbound TLS listeners, and whether you want to verify the TLS connection on the destination side. So a lot of folks have that as requirements. We talked about alternate ports. Alternate destinations are also supported. So you can write to a local disk file, you can write to a debug output, and then you can change for high volume, you can change scale kernel parameters to enable high scale. And we can scale one 8-core box to about 4 terabytes a day. So it is very, very scalable for high volume collection. And then lastly, configuration wise, this is what we call the unit file. So this goes in lib systemd, and this is how you launch SC4S out of systemd. So system control restart SC4S. I'll do that. I'll do a restart, and you will see on the left-hand side the startup process where we do a bunch of HEC test events to make sure our connectivity is good. And then we emit the version in a source type called SC4Events startup. So you can search for that, and that goes into Splunk, and then it's ready to go. So it's real easy to deploy on a single host, Linux host, directly out of systemd. So you really need to know nothing about containers to make this work. So here's the actual runtime, if you do want to run it by hand. And then all of these mounts are described here. So we mount the local file system to the container file system. And almost all of this is just turnkey. This is all documented in the documentation. So here you can, it tells you how the documentation is really good for getting going. And I highly recommend you go through this verbatim rather than trying to inject yourself in the middle. So it talks about what indexes we use by default in SC4S, and then the alternate add-ons that would help you, and for monitoring purposes. And then you select a particular runtime, and our most common one is Red Hat with systemd. And again, the unit file is literally cut and paste. Just copy it here out of the docs, and you can paste it in your Linux box. And then it talks about configuring the environment, including unique listening ports and all of that. So very simple to set up. And these mount points are literally cut and paste from the docs, and that gets you going out of the box. So that is it. Open it up to general questions.
Hey, Mark, we've actually had a couple of requests for the script that you have to generate this different syslog. I don't know if that's available or not.
I'll show you what they look like. Real simple. So all I do is echo the default to the screen here, but the motion, the script literally, and I can actually supply this, but this is it. So it's literally echoing the raw message with the date, so the date is current, and then just netcat with a write of 1 second, I think, delay, and then the SC4S server and the port you want. It's real simple. So I think I have. How many of these do I have?
Mark, I have
I got about half a dozen of these.
Cool.
Mark.
Yeah.
I have one more question. Like if a network team or network folks are sending the logs to SC4S, and if I'm not receiving, how do I troubleshoot those kind of
Errors,
problem?
yeah. There's a hole in the docs. There's a really good troubleshooting section. Back up here. So startup and validation, we go over what to do to start up. Main issue you're going to want to see here is journal control will be your friend if you're starting up out of system D. And if you're having trouble with system D, just run it by hand. And then just some ideas on how to troubleshoot. And then the main thing to look for is if you're in and things don't run properly, looking for the successful test of heck, and then these lines saying that it's starting successfully. If you have a syntax error, it will show up here. And if you do a journal control, I don't know if I have it in my history or not. Yeah, here's kind of the same thing. Here's the journal control output. It will tell you here what's wrong. So those are your two commands you want. This journal control command and the podman logs command. Those are the main ways to troubleshoot. And it's pretty verbose. It'll tell you if something's wrong pretty much out of the gate.
Thanks.
So couple of good troubleshooting sections here. This is the startup and validation, and then how you actually log. Here's some of the commands. Another thing that we ask for when customers come and say, hey, I want firewall foobar XYZ in SC4S, and it's not working. We'll often ask for on-the-wire raw events, and that is an event again that looks like with the 190. That looks like this. And any collection effort, in SC4S included, we omit the headers. So if you just send us what's in Splunk, that's not going to allow us to troubleshoot. We need the full raw event. And this section tells you how to get that. Either with TCP dump or configuring SC4S appropriately, you can get the full raw event. So we'll often ask for that. And support will often ask for that as well. Does that help?
Thanks, Mark.
Yep.
Thanks.
Any other questions before we wrap? Was this helpful? Right. Was this helpful to you folks? Hopefully it was.
Yep, it's more than helpful.
Cool.
All right, well, thank you very much, Mark. We really appreciate it. Thanks everybody for attending. I'll send out an email with the link to the recording and in the presentation and links to the other events that we have going on. But really appreciate everybody's attendance. I hope you have a great night, and we'll talk to you soon. Thanks again, Mark. Really appreciate it.
Take care. All right. Bye-bye.
Take care, everybody. Bye-bye.